So I'll be covering the module on traffic signal equipment today. This will be a combination of the updates that took place in 2016 as well as updates since then. So I just wanted to clarify that because I know some of the other modules focused more on updates that have happened since 2016, but this will also be tying in those updates as well. So this module will cover section 703 of the specifications, parts of section 1300 of the standards, and also section 512 will just briefly touch on temporary traffic signalization. Just want to note that this part of the module is not going to delve into traffic signal design details of design, but more how the standards and specifications and the updates relate and how designers can apply those when doing their traffic signal design. So we're gonna, sorry, I was a few slides behind. Okay, so we're gonna start with the brains of the operation, the traffic signal controller cabinet. Right now, VDOT is really working towards statewide consistency for the traffic signal controllers. And what does that mean? Right now, there's statewide contracts for the controllers. Those are McCain and Econolite. And there's also a statewide contract for firmware, and that is for D4 firmware. And that will help provide consistency across the state. All of those will be ATC cabinets or ATCs, Advanced Transportation Controllers. So in order to bring the specifications up to this level, there is an updated special provision that hasn't been released publicly, but it has been released through a few channels, and it will be released publicly in the future. And the special provision is updated to include information about the McCain controller, and it will be updated in the future as well to include information on the Econolite controller. So with the new ATCs, communications is important and helps support the enhancements that go along with these. The 2016 specifications called for the controller to be IP addressable. So what does that mean? That means each controller gets its own address that allows it to communicate with the network. So that communication can help in the future as we bring on new enhancements in technology when we're looking at connected vehicles, when we're looking at automated traffic signal performance metrics. It allows those to come into place by allowing controllers to communicate throughout the network. So we got a question from the audience during the break about who is responsible for controller programming. So this slide goes ahead and helps answer that. So previously, the contractor had been responsible for providing and developing timings. However, with the 2016 specification updates, it was clarified that VDOT now provides those timings. However, I understand certain districts have some different ways of doing this. So I wanted to see with multiple districts in the room if any districts want to speak up and comment on how their district differs in this. Okay, hearing none, I have heard that some districts, the timings are provided through projects, and then the project provides the timing. So that's acceptable as well. It varies throughout the state, but it does provide better clarification within the specifications. Also to mention that section 512 of the specifications states that signal timing during construction is developed and provided by the contractor. So just to recap, VDOT provides permanent traffic signal timings, and that may vary. Some projects may provide it in certain districts. And then for temporary traffic signals, the contractor provides that timing.
So VDOT provides the timing, but the contractor is responsible for programming the VDOT timings into the controller.
That's our understanding.
The pay item, measurement and payment for section 703 does say that timing implementation is part of the pay item.
I believe it says timing, development, and implementation, so if then VDOT is assuming responsibility for developing the timing, does that then negate the contractor's responsibility for programming? Is the contractor also then responsible, do they still maintain their responsibility for monitoring and adjusting off of VDOT timing? Can they override our timing?
What good Abdurrah says, she gets a no.
I'm not in the signal section, but to my limited knowledge, it's not. Because it's our operational, we're responsible for timing. Contractor do actual work and then we maintain, because later on, based on the circumstances, we'll adjust this time.
Correct, and that's what we're
Yeah.
some clarification, because if we hand the contractor the
Yeah,
timings, he's not gonna program it. Because he's saying that our timings is our responsibility.
I'm not sure about contractors, what he actually do.
Well, that's what I'm asking. What is his responsibility? What is our responsibility? Especially once we say we are going to provide you final timings program.
I wish somebody from our section could be here, so answer.
To be honest, I think this is a good question that we can take back to our signals team. I'm not in our signals team within traffic engineering division. I think you raise a very good point, and I think it's different in Nova versus the other districts, because in Nova, correct me if I'm wrong, basically you guys program the controller at your shop and give it to him, and all the contractor is doing is, physically installing the cabinet, and that's it. Like the cabinet comes kind of pre-wired, is that right?
No, that's not right. Well, the contractor will provide the timing, and the VDOT has to approve it. Once the VDOT approve the timing sheet, and then we'll send it back to the contractors, they have to program it
Okay,
at the field.
okay.
Yeah, we also have the remote control.
Right, but now this is saying that you gotta get rid of the timing, so you're no longer reviewing his time.
VDOT will approve the timing sheet and give it back to the contractors. It has to
Right.
get approval from VDOT. first.
Right, but this is not saying that you have to develop the
No,
final.
we don't.
VDOT will furnish controller timings for post-construction conditions.
And the specifications, I think, say that VDOT will furnish the control terms for post-construction conditions unless indicated otherwise in the contract documents. or something
That's
like
correct,
that.
yeah,
So
the department
they
is.
do indicate
yeah.
otherwise.
We
So
have all
I'm getting confused between the cabinet, which you guys provide
That's-
to the controller, which you guys do not.
Yeah.
I know in Richmond, we were trying to implement, ATC controllers, I think we actually did, like, maybe the first one or couple actually in shop, in-house, and provided back to the contractor, but I don't believe we do that on a normal basis.
Well, see, that's the problem, because now we're up here, same guys are doing it for Richmond for y'all, they're doing it for us.
Yep. Yeah.
They're actually being forced to program the controllers. And they're programming the controllers out of y'all's shop in Richmond.
Yeah.
So your shop in Richmond is programming controllers up here for us in Fredericksburg. And when we're telling them that they're wrong, they're saying it's done by VDOT.
Yes.
Yeah, because I think at least the first ATC cabinet, they did do that, so that might be where some of this discrepancy is coming from.
Yeah, because we just deployed 5 of them in Gloucester, and now Jim is having to do all of them.
Reprogram. But they were programmed by VDOT. But Fredericksburg didn't program them, Richmond programmed them. And then Richmond had to then reprogram them.
Well, Richmond, Fredericksburg, because we used to be central region before.
Well, you still are.
Well, that's right, Jim's the one doing the programming. Jim works for CRO, he doesn't work for us. But Jim's not the one that programmed them, I mean, it's
kind of messed up how
I'll
it
tell
is.
you what,
So
I
is this-
think we're not
yeah.
gonna solve this issue today, but what I can do is I'll tell the TED signals section to get in touch with you, Tom, you can talk about your issues. that you
Yeah,
have.
that'd be great.
That sounds great, thank you. Great. And then just something else to note on the traffic signal timings is that the clearance intervals need to be signed and sealed per TE 306.1 for both permanent and temporary signals. And again, who provides that may vary by district. So how does the signal then get accepted into the system? So the first step is there's a local intersection equipment testing, and that's two parts. There's the signal hardware testing, and that is the non-electrical equipment as mentioned in the specifications, such as junction boxes, conduit, but then there's also the electrical and electronic component testing, which could include items such as the local controllers. The second step of that is the signal systems communications testing, and that happens between the equipment testing and the demonstration testing. And then the last step is demonstration testing, and the demonstration testing period occurs for 30 days. And if there's any part of the signal that needs to be repaired or replaced during that time frame, that specific item or component then enters into an additional 30 days demonstration. So say 5 days into the demonstration testing period, something needs to be replaced. That specific item, then the demonstration testing period for that one item lasts another 5 days past the rest of the other demonstration testing that's taking place. So once all items have gone through that 30-day demonstration testing period, the signal can be accepted into the system. So for the next few slides, we're going to switch it up and dive a little more into accessible pedestrian signals.
Can you go back to the
Oh, yeah.
previous slide?
Yeah, definitely.
So, one of the signal equipment is installed by one contractor. The ITS stuff, the communications is by another contractor. Can we accept the signal first and then run the communication separate?
So the way the specification calls for, it does have the signal equipment testing happening separate from the communications testing. So that is two separate tests, but both of those have to happen before you then move on to the demonstration testing of the entire system being operable.
So the signal passes the final inspection, and the earliest VDOT can assume maintenance is 60 days following that?
Clarify where you're getting that from. I don't think.
Well, you're saying that the communications test has to be separate and before the demonstration test.
Yeah, they're looking at the communications. They're testing to make sure the communications equipment is functional
But
during
those two
that.
cannot be concurrent. It can't be the same 30 days. It has to be 30 days, 30 days.
It can be.
Yeah, that's what I thought, right?
Yeah, that's what we're trying.
Right, so,
Yeah.
okay.
Okay. Does that answer your question? Okay.
The flow chart's doesn't look correct, if you ask me.
Okay.
Because you're saying it's demonstrating 30-day testing, then you're saying 30 continuous days again at the end. So it should just.
Something was wrong with whatever.
Correct, that's what you got
The
to say at the bottom, going back and it says 30, but it should just be after demonstration
Right.
testing for 30 days is complete, then it should be accepted.
So we'll, yeah.
What the spec says and what's actually
Yeah.
happening in the real world, I think is what you're saying.
Yeah.
Not really.
Okay. We'll take a look at that and get back to you. Okay. So for the APS policy, we're an APS device, let me just kind of clarify that first, is a device that communicates in a non-visual format. So why is this important? Imagine approaching an intersection, not being able to see or being visually impaired, and most of the cues around you are visual cues. The traffic signal, the pedestrian signal, those are all visual cues. You can hear the cars going by you, but that doesn't indicate which way you can cross safely. So APS removes the barrier of signals being all visual by providing information to the visually impaired and the blind. So VDOT adopted a new IIM in 2017, IIM TE 388, which stated that APS should be incorporated in all signal alteration activities that involve pedestrian accommodations. So I want to note here that signal alterations per the IIM include new signals as well as signal modifications, and that APS needs to be implemented wherever there are pedestrian accommodations. So tied to that, I want to talk a little bit about some of the updates to the pedestrian actuation and how those tie back to the new APS requirements. So there's the PA3 standard, which is a 2-inch conduit that juts out of concrete. But when that's hit, because the conduit is in the concrete foundation, it can just bend over, and the concrete foundation then is very difficult to replace. So most of the time a new location needs to be found for a PA3. So a new PA4, which is more like a PF2, which has a small transformer base and is a minimum of 5 feet tall, was added to the standards. So the use of a PA3 versus a PA4 can be district preference. And just to note, the PA3 had been removed from the standards, but with the new APS policy, it's been added back in because it does provide additional help for that meeting that 10-inch reach associated with APS. So I'm going to spend some time specifically talking about that. I know that Michelle had hit a little bit on that and about the 10-inch maximum reach for APS previously. So while VDOT standards and specifications don't specifically call out a maximum 10-inch reach requirement, federal standards do. And so designers, when they lay out accessible pedestrian signal push buttons, should ensure that the face of the push button is within 10 inches of accessible distance. And that's for new signals. For modifications, they need to be to the maximum extent feasible, but still within 2 feet reach. So if you think about coming up to a pedestrian signal push button when you're sitting in a wheelchair, it's not just you. You then have the wheel and the arm of your wheelchair. So then you extend your arm out, and by the edge of the wheel, you don't have your full arm length to be able to reach up. So when you're pulling up next to a pedestrian push button, you may only have that 10 inches to be able to push the push button. So just wanted to explain that and why it's important to be able to get close. So continuing on with pedestrian actuation and pedestal pull, this continues to tie back to that 10-inch maximum reach. The PF2, and again, Michelle hit on this in the previous module, but the PF2 foundation may now be included as part of the 5-foot sidewalk. It may be installed. Some of the foundation may be installed flush with the sidewalk to be able to get it closer to the edge of the sidewalk and help meet that reach. It's important to note that the VDOT Road Design Manual requires that a 5-foot minimum sidewalk width, even at spot locations, such as for a pedestal pole, need to get a design waiver if you're going down to less than 5 feet. So it's important to still keep the pedestal pole outside of that 5 feet, but the foundation, as long as it's installed flush with the sidewalk, can be installed as part of that 5-foot sidewalk distance. Now this does take important thought through the construction process on part of the signal contractor to make sure the sequencing is correct, but proper layout will be really beneficial with APS design and helping meet that reach requirement. Yep, go ahead.
I have a question. For that 10-inch maximum reach distance, that pretty much saying that we cannot put the push button on the signal pole. Is that correct?
Yeah, so that's why there's a lot of different other options now with the the PA 3 and 4. Sorry, let me go back here. With the PA 3 and 4, as well as the PF2 standards, yes, those are the preferred methods to be able to get that reach.
Okay, how about?
Or there is now a mounting extender, which I'll talk a little bit about in later slides.
Okay, was this considered with a conflict or not with another standard that minimum lateral space between any fixed object is 1 foot from edge of sidewalk to any?
Oh, sorry, say that again?
So we have a standard, so
Yes.
minimum lateral clearance.
Minimum
any
ladder.
fixed object, it's a 1 foot from edge of sidewalk. So now it's push button need to be less than a foot.
Yes, so the push button needs to be less than a foot, but the foundation of the PF2 can be installed flush with the sidewalk to not create that barrier. So.
But pole but not supposed to be within a foot, right?
The pole the PF2 pole can be directly adjacent to the sidewalk with the new standard update.
It creates conflict with the 1 foot standard because we're not supposed to have anything at least 1 foot from a sidewalk. Shared use space even more. It's a 2 feet, 3 feet, and it's all described. With the standards, pretty much reflections of federal standards, but AASHTO. So
Yeah, we'll definitely have to look into that and get
Please
back
do.
to you on that.
Okay.
Yeah, that sounds
Thank
good. Thank you. So with all the changes to the APS, the changes that are brought about by the APS, in order to update the specifications to be in line with the new APS requirements and equipment, there is a draft APS special provision, and it outlines a lot of the requirements and design features associated with items that are unique to APS. This isn't published publicly, but it is in draft format currently. And as part of that APS special provision, there's a new pay item for accessible pedestrian system push button stations. And it's important to note that that pay item includes multiple items that are incidental, such as the signs, the pedestrian head control units, which are these units that go up in the pedestrian head and they send a message from the pedestrian head to the APS, and that's how the message is then communicated, or it's, so when the pedestrian signal changes, it triggers the APS message. There's also, as we mentioned earlier with one of the questions, there's a new pay item for a mounting extender, and this allows you, if you can't get the pole to be within that 10-inch minimum maximum reach distance, it allows the push button to be pulled off of the pole so that you can meet the reach distance required. So we're just going to touch really briefly on junction boxes. There is the R series and the S series. The R series is for traffic use. The S series is for non-deliberate traffic use, which can include use on shoulders. There's also a new standard for a JBS4, which is a larger junction box. And while there was a design for a JBR3, which is a larger junction box that could be used in the roadway, it's thought that that would be very rare that you would have a junction box that large in a roadway. So it's held as a special design drawing only, and it can be requested from central office if needed. And just to note that designers are responsible for sizing the junction boxes. So just to briefly also touch on sign mounting SMD, the sign mountings are included in the sign panel pay item, except they're not always in regional contracts. So if you have a regional contract that requires you to include a pay item and a quantity for those brackets. Refer to the special provision because the tables in the special provision outline for each manufacturer the number of square feet that is, or the number of brackets that's required based on square feet. It changes depending on manufacturer, so it's important to refer to those tables. So the next few slides, we're going to dive into the special provision for the mast arm hanger assembly. There were issues with cracked signal brackets across the state in the past, and so we wanted to define which manufacturers to use, and that's where this special provision came into play. It helps determine which manufacturers met the requirements. The issue with cracking had to do with torquing, and so there was different testing, and the special provision covers 3 major scenarios related to this: a new signal, a first relocation, and subsequent relocation. So as part of this, I first wanted to define the 2 main tables or terms that we're going to talk about. When there is a mast arm hanger assembly that is replaced in full, so all components, the entire thing is new, that is a complete mast arm hanger assembly. When there's only certain specified pieces that are replaced, that is the components assembly. So that'll be important as we dive into each of these scenarios. And we'll talk about the rules associated with each different type of relocation. So on a new mast arm, for a new hanger assembly, you only refer to the complete tables, which are tables 2 and 4 in the special provision. In the complete assembly, the information should be pulled from one of those 2. So that one is pretty simple. When you have a new mast arm, you have a new complete mast arm hanger assembly. So then we go on to the first relocation. So you have the mast arm hanger assembly installed, and you need to move it over. You have 2 options there. You can do an entire new mast arm hanger assembly or a complete mast arm hanger assembly. Or the second option is that you replace specific components as part of that mast arm hanger assembly. And those specific components and the manufacturers are called out in tables 1 and 3 in the special provision. So those are the 2 options for the first relocation of mast arm hanger assembly. So then what happens after you have relocated it once, when you're starting to relocate it a second or a third or a 4th time? So you have 3 options this time. The first 2 options that I just talked about apply again. So you can fully replace the mast arm hanger assembly. You can replace components of the mast arm hanger assembly. But what's unique to the 2nd, 3rd, 4th, any subsequent relocations after that first one is that you can reuse the hanger assembly, not the original one for the new installation, but the one after you relocate it one time. So you kind of see this little diagram of 3 signals up here and it jumping. So it's not that first installation, it's the subsequent one, the one in the middle. That one can be reused. Great. So, changing up topics, we're going to dive into the high visibility signal backplates. So high visibility signal backplates are low-cost safety measures, and they provide better visibility for signals in low light conditions. So at night, when it's foggy, in rainy conditions, or during power outages. And they've been shown to reduce crashes at signalized intersections by 15 to 30%. Now, there's recently been a change in VDOT's policy regarding high visibility signal backplates. previously, when a designer was looking as whether or not to install high visibility signal backplates at an intersection, they would go to IIM TE 378. Well, that's no longer applicable. Now, there's new direction that high visibility signal backplates should be installed across the state at all signals where feasible. So they should be installed on all new signals, and then for any existing signals that are being modified, high visibility signal backplates should be installed where feasible. For instance, if there's a need to upgrade structural in order to accommodate new backplates, then that would not be considered feasible. Also to note, there's a new supplemental specification that is pending for high visibility signal backplates. So we're just going to touch briefly on temporary traffic signals. There is a pay item for modify signal. And I want to clarify what the difference is between temporary traffic control signal and modify signal. So modify signal is for an existing signal location, but it can involve the contractor bringing in new traffic signal equipment. So just because they're modifying a signal doesn't mean that they're modifying only the signal equipment at the signal. They can bring in new equipment, and that is part of the pay item for modify signal. Also, I want to note that if a contractor chooses to utilize a portable traffic signal, that needs to be approved by the district traffic engineer before that's utilized. Also, I think mentioned way at the beginning of this training, there are updates to the traffic engineering design manual that will be coming out shortly, and I've heard that some of the updates are related to traffic signal or temporary traffic signals. Also want to note that the TS1 standard, which was for a typical one-way bridge signal, is now void. Temporary traffic signals should be designed on a case-by-case basis, and the signal designer should keep in mind pole relocation for specific phasing during construction, and ensure adequate right-of-way is available, especially if you're going to have guy wires that are parallel to span wires. Make sure that there's enough right-of-way available for those. For more information on that, refer to the Virginia Work Area Protection Manual or Section 512 of the specifications. And lastly, I just want to touch on pay items. I know we've talked about pay items throughout multiple modules in this training. And I just want to call out that there are now separate pay items. I think they used to be part of a supplemental specification, but they have now been added into the standard, or the specification, sorry. And they are separate pay items for the removal of specific existing traffic signal equipment. There's no longer a catch-all pay item for this. There is some equipment that is not specifically called out in the 2016 specifications, but is based on regional contracts. So with that, I'd like to take any questions or any discussion. I think I covered the two that we had. Actually, there is one question we received beforehand, and it's about APS policy. And the question is, does an update mandate the replacement of non-APS push buttons on existing crosswalks when adding a new crossing at the same signal? So let me go back to the IIM. So in the APS IIM, at the back there's an appendix, and the appendix has graphics that show when there's traffic signal modifications, exactly which push buttons need to be upgraded, and it's based on where the work is going to be touching and where the different pedestals that the work is going to be touching. Any other questions? Great, thank you.